What's up everyone, it's Perna, and welcome back to the channel. Today, we're diving deep into the future of software engineering. This isn't just about lines of code anymore. It's about understanding the tech that's reshaping how we build, interact with, and experience the digital world. We're talking AI, cloud computing, cybersecurity, and a whole lot more. Over the next few minutes, we'll unpack 15 key trends that are shaping the landscape for software engineers and basically anyone who uses technology. We'll break down complex concepts into bite-sized pieces, so whether you're a seasoned developer or just curious about the future of tech, stick around. This is your roadmap to understanding where software engineering is headed. So, grab your favorite drink, get comfy, and let's jump right in. First up, let's talk AI and automation. And no, I'm not talking about robots taking over the world, at least not yet. We're seeing AI change the game in software development, making things faster and more efficient. Think AI-powered tools that can actually write code, helping developers breeze through repetitive tasks. This frees them up to focus on the complex and creative stuff. It's like having a super-powered coding assistant. But it's not just about speed. AI brings precision to the table too. We're talking fewer bugs and more reliable software. From automating testing to optimizing code, AI is becoming an essential co-pilot for software engineers. This is just the beginning, guys. As AI continues to evolve, expect even bigger changes in how we build and experience software. Now, let's zoom in on a specific flavor of AI machine learning. This is where things get really interesting. Imagine software that learns from data and gets better over time. That's machine learning in action. For software engineers, it's like having a superpower. They're using machine learning to build smarter applications, the kind that can personalize your experience, predict what you need, and even understand your emotions. From recommendation engines that suggest what to watch next to fraud detection systems that keep your money safe, machine learning is powering some of the most innovative software out there. With AI and machine learning becoming such game changers, there's a huge demand for software engineers who can speak the language of data. It's not enough to just write code anymore. You need to understand how to work with data, analyze it, and use it to build intelligent applications. That's where AI literacy and data science come in. Think of it like this. If you want to build a house, you need to know more than just how to hammer a nail. You need to understand blueprints, materials, and structural integrity. The same goes for software engineering in the age of AI. You need a strong foundation in data science and AI concepts to build the next generation of intelligent applications. Okay, let's talk about the cloud. No, not the fluffy white things in the sky, but the network of servers that power so much of our digital world. Cloud computing has revolutionized software engineering. Instead of being tied to physical servers, applications are now living in the cloud, accessible from anywhere with an internet connection. This means software engineers need to be skilled in building cloud-native applications designed specifically for the cloud environment. Think scalability, the ability to handle massive amounts of traffic, and resilience, the ability to bounce back from failures. These are key concepts for software engineers working in the cloud. As software becomes more complex, we're seeing a shift towards distributed systems and microservices. Think of it like this. Instead of building one giant monolithic application, you break it down into smaller, independent services that communicate with each other. This approach makes software easier to develop, deploy, and scale, but it also requires expertise in tools like Kubernetes for container orchestration, Docker for containerization, and serverless computing platforms like AWS Lambda. These technologies help manage and orchestrate these distributed systems, ensuring they run smoothly and efficiently. In a world increasingly reliant on software, security is paramount. We're talking about protecting sensitive data, preventing breaches, and ensuring trust in the digital world. For software engineers, this means integrating security into every stage of the development process, not just as an afterthought. We're talking about writing secure code, implementing robust authentication measures, and staying ahead of the curve when it comes to the latest threats. It's a constant cat-and-mouse game, but it's one that software engineers need to be prepared for. Speaking of security, DevOps is another area where it's crucial. DevOps is all about breaking down silos between development and operations teams, enabling faster and more efficient software delivery. But with speed comes the responsibility of ensuring security is baked into every step of the process. That's where secure DevOps comes in. It's about integrating security practices into the DevOps workflow, from code analysis to vulnerability scanning to penetration testing. Software engineers need to have a deep understanding of vulnerabilities, threat modeling, and secure DevOps practices to protect user data and maintain the integrity of their applications. Now let's talk about how software gets made. Agile and DevOps methodologies are like the dynamic duo of software development, emphasizing collaboration, automation, and continuous delivery. Agile is all about being flexible and iterative, responding to changes quickly and efficiently. It's like building a house one room at a time, getting feedback along the way and making adjustments as needed. DevOps takes it a step further by automating the entire software delivery pipeline, from code integration to testing to deployment. This allows for faster release cycles, quicker feedback loops, and ultimately, better software. Software engineers who master Agile and DevOps principles will be in high demand as companies strive to deliver high-quality software at lightning speed. Remember how we talked about AI and data science changing the game? Well, it's also transforming how software is developed. AI-driven analytics tools are giving software engineers superpowers, helping them understand user behavior, identify bottlenecks, and optimize performance like never before. Imagine having a tool that tells you exactly where users are getting stuck in your app or which features are most popular. That's the power of AI-driven analytics. By integrating these tools into their workflows, software engineers can make data-driven decisions, improve the user experience, and ultimately build better software. Okay, get ready for this one because we're stepping into the realm of science fiction. Or is it science fact? Quantum computing. This technology harnesses the mind-bending principles of quantum mechanics to perform calculations at speeds that would make traditional computers look like snails. We're talking about solving problems that were previously impossible, like simulating complex molecules to develop new drugs or optimizing logistics and supply chains on a global scale. While still in its early stages, quantum computing has the potential to revolutionize software engineering and open up a whole new world of possibilities. Now you might be wondering, how do you even program a quantum computer? Well, it's a whole new world, my friends. Software engineers will need to wrap their heads around quantum algorithms, which are fundamentally different from classical algorithms. They'll need to learn new programming languages like Qiskit, an open-source quantum software development kit developed by IBM. It's like learning to speak Klingon, but instead of communicating with aliens, you're communicating with qubits. As quantum computing matures, mastering these skills will be essential for software engineers at the forefront of this technological revolution. Let's face it, technology has an environmental impact. From the energy used to power data centers to the e-waste generated by discarded devices, it's something we need to address. That's where green software engineering comes in. It's about building software with sustainability in mind, reducing its carbon footprint, and minimizing its impact on the environment. This means writing energy-efficient code, optimizing algorithms for minimal resource usage, and choosing eco-friendly cloud providers. As awareness of environmental issues grows, software engineers who prioritize sustainability will be in high demand. At the end of the day, software is for people. That's why human-centered design remains a top priority in software engineering. It's about understanding user needs, designing intuitive interfaces, and creating software that is a joy to use. This includes incorporating the latest technologies like augmented reality, virtual reality, and voice interfaces to create more immersive and engaging experiences. Software engineers who can empathize with users and create human-centric solutions will be the ones who shape the future of technology. The world of software engineering is constantly evolving. New languages, frameworks, and tools emerge at a dizzying pace. To stay ahead of the curve, software engineers need to embrace continuous learning as a way of life. Whether it's taking online courses, attending conferences, or experimenting with new technologies, the key is to never stop learning. The most successful software engineers are the ones who are adaptable, curious, and always eager to expand their skill set. So, there you have it. The 15 key trends shaping the future of software engineering. It's a dynamic and exciting field, full of challenges and opportunities. To thrive in this ever-changing landscape, software engineers need to be adaptable, forward-thinking, and always willing to learn. The future belongs to those who can embrace change, push the boundaries of what's possible, and use technology to create a better world. Remember, the only constant in software engineering is change itself. So stay curious, stay creative, and keep on coding. That was a whirlwind tour of the future of software engineering. I hope you found it informative and maybe even a little bit mind-blowing. If you're as excited about the future of tech as I am, hit that like button and subscribe to the channel for more deep dives into the world of software engineering. And be sure to let me know in the comments what trends you're most excited about or any questions you have. Until next time, keep innovating.